All right, so this is sampling distribution lecture number 1, an introduction to what sampling distributions are. We'll see that when we talk about sampling distributions, this is probably the most theoretical piece that we're going to discuss in this class, but it's also, of course, one of the most important. So let's first talk a little bit about samples versus populations. Remember, we talked early at the start of the course about something called an inferential statistic, a statistic that's used to draw conclusions about populations, which are generally very large and too big to measure, and samples, which are subsets of people from those populations. Now, a great example of using samples to draw conclusions about population is election polling. With election polls, you ask a small set of people how they're going to vote, and you use that to project what the actual outcome for the presidential election would be. So, for example, in 2016, there were over 130 million votes cast for president. We'd never be able to do a survey that asked all of those people who they planned to vote for. Instead, we take a very small sample, and I think you'll be surprised at how small a sample can be and still be accurate. We take a very small sample, and we use that to draw conclusions about the election. All right, so let's just take a look at the 2016 presidential poll. Among the national election polls that we'll talk about, all of them closed between the 5th and the 7th of November. That is the days right before the election that happened on the 8th. The median sample size, you might be surprised to learn, was about 1,400. That is, these are not big samples. And we'll talk about why you don't actually need a big sample to get an accurate result. The polls overwhelmingly favored a Clinton victory, and I need to be clear there that those polls were projecting the overall national vote rather than the Electoral College vote. So just to give you an example from one of the polls, here's how a typical poll might be conducted. Bloomberg Politics, one of the major polling companies, contacted about 800 adults who were likely voters over the internet. They usually ask a set of questions determining how likely someone is to vote, how strongly they believe that they're going to vote, because they only want people who are likely to vote to be in the poll. The margin of sampling error is roughly plus or minus 3.5 percentage points. We'll talk about this thing, the margin of error, in a great deal of detail in this module. So what does that margin of error mean? Well, polls will commonly present not only a raw statistical value, such as this percentage said this percentage said this, but they'll also include what's called a margin of error. The margin of error lets us know how precise we should view that estimate. So it tells us what sort of range of results we could reasonably expect in the actual distribution or in the population. So for example, if 50% of voters said that they would vote for a certain candidate, that poll is not saying 50% of people are going to vote for that candidate. That's saying 50% of people in our poll said they would vote for the candidate. We have a margin of error of 10%. Therefore, what the poll is saying is that we expect somewhere between 40 and 60% to vote for that specific candidate. So that's how the margin of error works. It kind of tells us how precise or imprecise in this example some information is. If the margin of error was 5%, it would suggest 45 to 55% would vote for a certain candidate. So here's an actual question from an actual poll. If the general election were held today, the candidates were, and they have a list, generally a rotating list, for whom would you vote? Here are the results from that Bloomberg poll. 46% versus 43%. Does that mean necessarily that they're predicting a 3% victory? No, or a 3% victory in terms of the popular vote? No, it doesn't mean that. What it means is if the margin of error is 3.5%, we would expect, this poll is saying somewhere between 43 and 49.5% of the voters are going to vote for Clinton, somewhere between 39.5 and 46.5 would vote for the other candidate. So what this poll was actually saying is, okay, there's a chance that either candidate would win the popular vote, but it seems more likely that Hillary Clinton would be winning the popular vote. The actual election results, Clinton 48.2%, the other candidate 46.1%. And one thing to note here is that that is well within this range that they predicted. So this poll was very, very accurate. So the poll wasn't wrong. The poll was actually very accurate. And when you think about it, being able to get that sort of accuracy with only 800 people, it really does speak to how powerful this idea is that we can draw conclusions about populations based on samples. You may be asking yourself, hey, but if Clinton won the popular vote, how come she's not the president? There's this quote here, the Electoral College is designed to ensure that the office of president will never fall to any man who is not in eminent degree endowed with the required qualifications. The Electoral College ensures the president is chosen by the men most capable of analyzing the qualities adapted to the station and acting under circumstances favorable to deliberation and a judicious combination of all the reasons and inducements which were proper to govern their choices. That quote, of course, is from Alexander Hamilton. Alexander Hamilton. I kind of like the musical a lot more than his stance on the Electoral College. So if a poll said 50%, 46%, and you saw these margins of error, none of these outcomes except for the final outcome would be surprising, the one where we have 56% and 40%, because those results actually fall outside of that range, outside of that interval that margin of error has provided for us. So what exactly is the margin of error? How do we know how much error there is? And this all goes back to the normal distribution. We're going to see that the normal distribution actually gives us a lot of information that we can use to leverage all kinds of new and exciting statistics. It's a function of the sample size and the standard deviation in the population, which is noted with the Greek symbol sigma. I think this might be the first Greek symbol we see. In general, in statistics, and well, it's a little inconsistent, but in general, if you see a Greek symbol, it means it's a statistic related to a population. Symbols in our alphabet mean it's a symbol related to a sample. So what makes the margin of error smaller? Well, let's take a look at what a typical margin of error would be for different polls. 5% margin of error is what you get when you have about 500 respondents. 4% margin of error is what you get with 625 respondents. To get to a 3% margin, you'd need 1,100. 2%, you'd need 2,500, and then 1%, you need actually 10,000 respondents. You can see here, as the sample size is going, as you ask more people, you have less error. And you can also see why a lot of these polls maybe hover around 800 or so participants, because the payoff for having so many more people is relatively minor. It's a relatively minor payoff in terms of margin of error. You have to start adding a lot of people to get above 3%. In fact, I don't think you'd see many polls that have margins of errors that are that are less than 3%. Turning to what the different polls said, the line there represents 0 with the right side favoring Clinton victory in the popular vote. You can see that only one poll actually fell on the other side, and even that poll, its range included some stuff with a Clinton victory. That's also a very conservative leaning poll, which is some polls are biased in certain ways. So you can see where the actual result fell. Most of the polls here hit right on, have their intervals hitting in that result. So most of them were very accurate. All right, turning to the current election, here's what the 2020 polls look like, with the thick line representing 0, everything to the right favoring a Biden win. And you can see that at this point, the election, at least the results from September 9th, the election certainly seems to be skewing toward Biden over the other candidate. All right. Next up, we'll talk about